all right, everyone. I'm happy to introduce Lu Sun, who is a PhD candidate from UC San Diego. Her research has been focused on AI, especially scaffolding knowledge work. For tasks including some sense making and also scientific writing. She is also her research also look into evaluating the trustworthiness and faithfulness of generated text. And some of us might be already familiar with her work related to tools to support academic reviews. And so with that, I'll have Lu Sun take it away, please.
Thank you for introduction and thank you for having me here. As we have already experienced as a researcher, research progress relies heavily on peer-reviewed publications and conferences, which serve as a platform for sharing scientific findings. This entire process is built upon a robust peer-review ecosystem. So today I'm going to introduce from guidelines to interactive guidance, AI system to scaffold the academic peer-review ecosystem. Peer review is a collaborative and multi-stage process, and it varies in each single venue. Here's an example we might be very familiar with in a conference such as CHI and ACM and LP conference. This peer review ecosystem involves authors who are the main people driving the research, independent reviewers, or in some venue, we also have meta reviewers who are making the final decisions. They all interact within the same scientific environment. Authors submit their work, reviewers write their reviews. Some research venues may involve meta reviewer to assess the reviews, solve conflicts, and write a meta review that explains the decision. Recent data shows that this ecosystem is facing several challenges. Meta research communities are seeing a rapid increase in submission. For example, in the HCI conference, CHI, the submission increased 50% compared with 2016. A more extreme example is the NeurOps conference in a machine learning research venue. The numbers of submissions nearly increased exponentially, going from 2,000 to over 10,000 submissions at 2023. We also see more novice reviewers involved in this peer review process. To give you some idea of this, in the CHI 2023 conference status, in 5 out of 18 subcommittees, the majority were playing the meta reviewers or ACs roles for their first time. Very few ACs have 4 or more years of experience in that role. There were many first-time ACs, or likely many first-time reviewers, entered into this process. But reviewers usually trained on conducting research. There's usually no specific training designed for peer review writing. So the current review system, PCS, which is used for many HCI conference, as an example shown here, provided several questions as review considerations. Many individual labs train their students to write reviews different way, but the guidelines provided by the community tend to be a little bit generic, static, and only focus on the final outcomes, namely the written review and the decision, rather than the process of doing a review. However, the complexity of comprehending, decision-making, and writing reviews make this task cognitive demanding and difficult for analysis. So faced with the challenge of large volume of submissions, can AI help? Recently, we do see AI is trying to help researchers in lots of research steps. For example, GPT, some of the scholars are powerful tools to support research process, such as literature searching and writing. But should we just use AI to write the reviews or solve this issue? We see some communities already react negatively to the reviews that they perceived as being written by GPT. For example, here the person complained that if they want to know what the GPT thought about a paper, I could just ask myself. So faced with this challenge of increasing volumes of submissions and potential concerns of using AI, I've drawn insights from learning science and cognitive theories and employed the scaffolding strategy with AI to help novices think and potentially perform better when they enter into the review process. So what is scaffolding? By definition, scaffolding is the support given to students by an instructor throughout the learning process. Research in various learning contexts has explored the concept scaffolding and found that this strategy can promote the deep levels of learning. Scaffolding take many forms. Take a poster design as an example. Scaffolding can be provided as written guidelines. It can be various poster examples, or it can be context-specific hints, or it can be a Seeing these scaffolding strategies, it can be as general as guidelines or as contextual as providing specific examples and hints by adapting the scaffolding to meet learners where they're at. And this is the interactive contextual scaffolding we're exploring in the research. Scaffolding strategies are frequently used in intelligent tutoring systems. Systems like math tutor and cognitive tutor are trying to guide learners through using process-oriented scaffolding. For example, they provide step-by-step hints or chatbot conversation to help guide learners when they solve math problems. These tools are not just giving the correct answer, they're trying to engage the learners to understand how to get to the right answer. Scaffolding can also operate outside of an explicit learning scenario. For example, there were numbers of systems to scaffold writing. The system Intro Assist helps novices draft email to request help from busy experts by providing guidelines and example emails. Lettersmith went a bit further by providing checking lists and color-coded examples. Here, scaffolding allows users to self-annotate and compare their writing with an example. By reviewing the system, I start to realize some dimensions of scaffolding that have been using here. I mentioned the scaffolding can be generic like guidelines, or it can be contextual like adaptive hints or examples. Another dimension is whether this scaffolding only focuses on the outcomes, or it can guide the process to achieve the desired outcomes. Intro Assist and Lettersmith mainly provided scaffolding at the end. The goal of scaffolding is to focus on the outcomes, which is deliver a higher quality written email at the end. On the other hand, the step-by-step guidance provided by Math Tutor used process-oriented scaffolding, which tend to help with each intermediate step. For a type of task that is complex and usually contains multiple stage activities, learners tend to embed guidance throughout the process intelligently to reduce the cognitive load and gradually improve learning. So it becomes necessary for scaffolding to be process-oriented and adaptive to the workflow context, which shows at the upper right corner in this design space. The academic peer review process and loss of knowledge process is one example of this type of multi-step activities that involve different considerations and nuances. So my research is providing contextual, process-oriented, and self-reflective AI-driven scaffolding, which can provide opportunity support for novices on complex knowledge activities. Specifically, I focus on the peer review ecosystem. To scaffold reviewers, I designed ReviewFlow platform that supports novice reviewers by guiding them through the review writing workflow. Likewise, I developed MetaWriter to scaffold meta reviewers in the meta review writing and decision-making process. Last, I will talk about some ongoing projects to scaffold authors in this ecosystem and potential collaboration projects with AI too. I will start with introducing ReviewFlow. In this project, we explore how to intelligently scaffold support novice reviewers in a workflow. We tend to answer three main research questions in this project. First, what are the challenges faced by novices, and what strategies usually adopted by experienced reviewers? So we ran a formative study that first interviewed 10 novices, and then to capture their challenges, we didn't conduct observational study with 10 experienced reviewers who had more than 4 years of review experience before. We asked them to conduct a review on a short paper and observe their common practices and strategies. Based on the formative study, we identified design goals and design AI scaffolding strategies correspondingly. Here we seek to answer how can we intelligently scaffold the review process. We developed the ReviewFlow system by evaluating the system in a within-subject experiment. Then during this comparison, we want to answer how does this intelligent scaffolding in the ReviewFlow affect the review quality, process, and perceptions. Here shows the process that experienced reviewers took during the observational study. For example, this expert is reading the papers while taking several notes on the plausible questions and evaluate each dimensions. After they finish reading the paper, they first outline the main problems appears in the paper, then expand on top of these topics to explain the main points. At the end, they tend to revise their draft. By observing 10 experts, we found that many experts adopt a workflow involve critical reading, annotating, note-taking, and synthesizing a well-justified reviews. In the stage of reading and comprehend, novices reflect that they lack opportune considerations for assessments. In the stage of evaluate and assess the paper, novices are not confident about their domain knowledge for novelty concerns. Some features to provide knowledge supports are needed. In the review writing stage, novices reflect that they lack guidance on how and process and structures. They also uncertain about whether the tone they delivered in the review is appropriate, although their review meets the community's expectation. Correspondingly, we propose scaffolding features to support each of the stage. Here's the overview of the system on writing reviews for a short CSCW paper. ReviewFlow lists the papers on the left, notes in the middle, and have a review draft panel on the right. Users can highlight a part of text that they would like to reflect on and pick a review criteria, such as importance to CSCW. And then ReviewFlow provides an adaptive reflective question using the selected paper content and the community guideline. This question is asking the user to reflect, how does this paper contribute to our understanding and enhancement of CSCW in virtual studying setting amidst privacy and self-aware concerns? These cues or questions are also provided in the section level, which shows next to each section header. Reviewers can write their answers, and then when they press save, they will save to the middle panel of the notes. When users read the related work section, ReviewFlow will recommend 3 papers that are potentially related in the same topic and the same venue but not get cited. Users can check to get further information around this research area. For each citation, the user hover on it, a pop-up card will show contextually with the basic information of the paper. When users finish note-taking, they can click the Summarize My Notes button at the bottom, where the system will only take their written notes, text, together with the PDF content as input to generate an outline with broader topics. When users click on each topic, the system will highlight the corresponding notes and PDF content to help them fact-check on the topic. User can add more strengths and weakness topics. Then the user can select to expand these topics into a longer outline version with a specific bullet under each topic. User can reuse the content to write their own writing. And when they have already made a decision and submit, they're asked to self-reflect on their writing draft, on their tone, comprehensiveness, and constructiveness. Here shows the framework of how we built the ReviewFlow system. We obtain the PDF from the authors. We extract PDF content using Girlbit. They provide us the JSON format of the PDF file. We then use only we don't only use the content that users selected, where they're highlighted, and the abstract of the paper, and throw this information into GPT and ask them to provide us reflective questions and notes outlines. For the recommended paper, we use the Semantic Scholar API, where we only throw in the keywords provided by the authors, and then we search for the similar papers but not get cited. These data are stored in a database, and there's a login system for users to use the ReviewFlow interface. We conducted within-subject experiments where we recruited 16 inexperienced reviewers to write reviews using ReviewFlow and the baseline system. The baseline system contains minimum guidance in a counterbalance order. All participants conducted reviews on 2 HCI short papers with more than 24 hours interval in between. They also fill out the surveys and being interviewed at the end. The measurements we collected include experts' rating on the final written review quality, on reviewers' time spent on the task, and their engagement with the system, and their perceptions of benefits and challenges. To evaluate the review quality, we invited 2 expert reviewers to read the paper and review, and then provide ratings on each dimensions of the review quality from 1 to 7 Likert scale, including tone, comprehensiveness, constructiveness, justified, and our overall score. We found that ReviewFlow helped participants write like more comprehensive reviews, where they called out more strengths and weakness in the paper. However, there's no significant improvement in the constructiveness of the review. We also found participants took a significantly longer time to read papers with ReviewFlow, but a slightly shorter time on drafting the final review than baseline. Participants reflect that they spend more time on carefully evaluating the paper and answering contextual questions proposed by ReviewFlow. Participants also reflect that they are more confident about their review writing skills after experiencing ReviewFlow. P11 mentioned that I feel I gradually built confidence. At the beginning, I would try to answer every question, but later on, I started to remember which aspect I should think of when reading that section. In a post-interview, participants also expressed their concerns that last-minute reviewers may randomly leave notes and then just use the tool to generate it online. Expand the notes, it may not be truly reflective of what they're thinking. This misuse of tool will not be fair for paper authors and the research community in general. To sum up, contextual and process-oriented scaffolding can help novice reviewers to write a better review, although taking a longer time. In a study, novices reflect that the scaffolding helped them gain confidence and learn the process. The study also reflects some tensions of using AI. Participants did not express severe concerns in the study section since the generated outline is merely reused or summarized their notes. However, they were still worried about the nuanced tones in the outlines produced by AI may exaggerate the weakness of the paper and influence the reviewer's perception. Moreover, participants expressed their concerns of other reviewers in the research community. The misuse of the tool will bring fairness issues in the research community in general. So to dive deep into these concerns, we further explore the trade-offs of using AI scaffolding in a peer review in the next project. But I would like to stop here to take clarification questions.
Just a quick question.
Mm-hmm.
So for the recommended papers that you fetch from Semantic Scholar, are you using it in any way beyond just saying like, here are some papers that you can look at?
I think there's two points we used the Semantic Scholar API. One, we threw out the papers keywords and top keywords into the Semantic Scholar, and then search and rank it by the recency, and then we search for the top papers, 100 papers, and then filtered out the papers that already got cited and display it on the related work section. The second place we use Semantic Scholar API is we create for each cited paper, we create back to show the TLDR information, authors information, year, conferences.
So you don't actually integrate information about our recommended paper into the generated text in the outline, right? Okay.
We don't. But if they kind of like make notes on, if they check out these papers and then they highlight these papers and they take notes in it, it will be got integrated.
Okay. Jonathan has a hand.
Hey, could you explain the design decision for the experimental design to, it sounds like you didn't control for time. So why did you make that design decision, and how do you know that the intervention isn't effective just because it makes people take more time?
That's an interesting question. We have recommended time. We tell them that you can spend as much time as you want, because we don't want them to get too tired. So we recommend them to spend like less than 2 hours on our task. But we do compare time because we want to see whether they're willing to spend more time engaging with the system, like more or less compared with like the baseline system. Or does this like a system help them improve their efficiency of reading and writing? But the results is like they kind of spend more time on the ReviewFlow system, so it didn't make the process faster. It only make it faster in the writing stage. So we kind of use time as a measurement to compare like their engagement. And I think this is also a good like kind of measurements reflect on whether they carefully read the paper or they thinking more about different considerations.
As a follow-up question on that, do they actually read more paper, as in ReviewFlow encourage people to read more papers when they do review, or not?
They take longer time on reading the paper.
What about the number of paper?
You mean because people only...
Oh, you mean the paper itself? I got it now. Okay, I was thinking about the reading time, including the time of reading recommended paper as well, but I don't think you measure. I don't think that was measured, but that's fine.
Yeah, we do measure whether they click on it.
I see, got it.
Yes, so there's a numbers like how much time they click on it, but we don't have that in a baseline system, so we cannot compare that.
Makes sense. Okay, thank you.
But we do kind of worried about the the order effect, so we kind of set up like a 24 hours interval between at least 24 hours between two sessions. Okay, I'll keep going. Sorry, actually I cannot see the audience, so if you have questions, you can just speak out and then I can hear that. So we further, faced with the concerns we have in a ReviewFlow, we further explored the trade-offs of using AI scaffolding in peer review in a MetaWriter project. Some communities involve meta reviewers to summarize independent reviews and deliver a final decision. But meta reviewers' task sometimes becomes very challenging, especially in some communities have large paper volumes. First, peer reviews provided by individual reviewers can be very long. Meta reviewers not only need to read 15 pages long submissions, but often need to read and summarize up to 2 to 3 pages of individual reviews. Among these long reviews, it is also hard for meta reviewers to cover or consider every single aspect of the review. Meta reviewers also need to solve this conflict between reviewers and make a fair and accurate decision. For example, in one of the iClear review, on the left, the reviewer said that the paper is generally well written, but another reviewer saying this paper was a bit dense and hard to follow. Faced with these challenges, we designed MetaWriter interface. This interface is built on based on the Open Review platform, which is used for iClear conference. When the meta reviewers enter into the system, MetaWriter tags sentences based on the relevance to categories like originalities or validity. Then it pinpoints, users can select and check which text they want to consider, and it also pinpoints the important information from each review, so reviewers can hover on each key question sentences to find the locations and understand what each reviewer considered most critical. Meta reviewers can also leave some notes. When the meta reviewer is ready to draft the meta review, MetaWriter provides a preliminary draft that compiles these points, offer a template to build from. But importantly, this draft is not automatically included. Users have to actively choose to view it, ensuring they remain engaged in the decision-making process. At the end, users need to make their own decision and write a review, but they cannot copy-paste the entire paragraph. When we design this system, we are really focusing on a scaffold inexperienced meta reviewers, trying to highlight the structure within the review and support the process. And also, we want to give reviewers as much agency as we could through deliberate edits. There are 3 main AI scaffolding features, include color-coded tags, extractive sentences to support a meta review process, and the draft meta review on the right for participants to use as inspirations and starting point. Users need to toggle to read or hide the meta review if they think the draft might influence their judgment of the paper. Sentences that include decisions are removed from the generated draft. So if you have questions, please feel free to check out the paper for more technical details. MetaWriter provides 3 AI scaffolding features using fine-tuned models. So first, the automatic tagger can tag and highlight different aspects of reviews. Second, the extractive summarization model can select important sentences from from independent reviews. We collect a data set by ourselves from 5 years iClear data, and then we fine-tune the pre-sum model, which is extractive summarization model, to identify important sentences from each paper. Then the machine-generated meta review draft is generated based on the paper content, and it also provides a draft that can be further edited. We fine-tune the bot model to generate this meta review draft, where we provided selected sentences, ratings, and the paper abstract for the model to generate it. I would like to mention that there's one opportunity to expand this model across different domains. We choose to fine-tune these models because we want to preserve the the data, the privacy of the data we use, the PDF data we use in this experiment. So here shows the architectures of how we build up the MetaWriter interface. So we got the Open Review link. We use web scraper provided by the Open Review platform, and we store the reviews into a GPU server, and then we start to run the GPU server, which runs an abstract tagger, which runs the fine-tuned pre-sum model to extractive summarize the review. And then we also ran a fine-tuned bot model to abstractively summarize these reviews into a draft. We then got all of these results. We store these generated data and use the data in a remote server, and then render all of this information into the front-end interface. In this project, we tend to answer 3 research questions. How does MetaWriter impact the quality of meta reviews in terms of efficiency and perceptions of the agency? How does prior experience as a meta reviewer affect the performance and perspectives on the intelligent scaffolding? And how do paper authors react to this MetaWriter interface? In the first study, we ran a within subject experiments to answer the first and second research question. We conduct this experiment to compare the MetaWriter with a baseline editor, which has the same interface without any AI features. We focus on these 2 questions, and we recruited 32 ML researchers with mixed review experience. They were asked to conduct 2 meta reviews on two machine learning papers on the same topic. Meta reviews written by MetaWriter was significantly better at summarizing the paper contribution, covering the independent reviews, and justifying decision compared with a meta review written in the baseline system. By comparing meta reviews in these 2 groups, we found that participants wrote more or less diverse draft using MetaWriter. One reason might be because they reused generative summary of the paper within their own writing. We also found the cosine similarity between the draft and the original iClear meta review in the MetaWriter was significantly higher than the baseline condition. So it seems with MetaWriter, participants tend to land closer to the original iClear meta review. MetaWriter reduced the time for participants to write meta review compared with the baseline editor. MetaWriter led both experienced and inexperienced participants to write significantly more justified reviews. So by comparing these 2 groups, inexperienced meta reviewers benefits more value in terms of covering more points in their meta review. MetaWriter seems to provide most value to inexperienced participants in terms of scaffolding and initial structure, which can be daunting for first-timers. And more experienced meta reviewers perceive the meta review draft as helpful and more likely to trust them. Peer review ecosystem involved multiple stakeholders. So we further interviewed paper authors to understand their reactions to MetaWriter. So we conducted 30 minutes semi-structured interview with 6 iClear paper authors. In an interview study with authors, half of the authors reflect that this tool could be helpful as a training tool or help with the visualization aspect in a meta review process. But they were concerned that the meta reviewers may over-rely on the generative draft and not put enough efforts into writing constructive feedback. So A3 mentioned that I feel it's okay to use MetaWriter tool to help summarize the review, or a visualization tool, but I do need to see evidence that meta reviewers has put their efforts and thoughts into it. I would be upset if my paper is rejected solely based on the output of MetaWriter. To sum up, like both experienced and inexperienced meta reviewers benefits from scaffolding in terms of quality and efficiency. By comparing different levels of scaffolding, we found that like experienced reviewers appreciate a meta review draft, and inexperienced meta reviewers got benefits from process support. But during the study, authors emphasized the concerns of how the code community might use this file in the peer review ecosystem. So I would like to discuss like these questions in further. Like I will also be curious about what you guys think about how we can defend against misuse, improve trust within these peer review communities that we are part of. How we can make AI system more transparent and fair without adding cognitive complexity, and what are the ethical concerns there. And next, I will jump into the ongoing project, but before that, I will do a quick break to take any clarification question.
I have a quick question. What is the context that you use for your study setup when you ask the author to provide feedback? Is this after they already submit the paper and actually receive actual meta review?
You mean like the author interview?
Yeah, the author interviews.
So in an author interview, we didn't ask them to use the system, but we do show the system, and then like the scenario is set it up like, oh, if you have received these meta reviews, and this is a system out there that people like meta reviewers may potentially use, how do you perceive this as an author?
Got it.
Cool. And I'll keep going. So I have been talking about projects focused on the reviewer side and meta reviewer side. For the ongoing project, I'm focusing on the author side. One aspect to close this loop is that authors need to revise their paper and write a prospective rebuttal when they receive the feedback from the peer review. So we developed this revision support system that when authors receive and read through feedback from peer reviewers, we try to scaffold their thinking, then contextually provided some like strategies they can take action on, or some reflection questions. I will show. Here's a brief overview of the system. I think the video is now playing. But as you can see there, like there's a PDF on the left. Then when the authors receive the reviews, they can highlight part of the reviews, and then the system will give them some strategies they can use, or some reflection questions they can like think about. And then when they take notes, they can keep these strategies in mind, and then take their own notes to see whether they want to accept these suggestions, provided by the GPT model, or they want to do further actions. And later on, the model will generate an outline for them to, and a to-do list for them to write a rebuttal on their paper. Another project I'm thinking about is to potentially collaborate with AI tools specifically, is on the aspect that we can give authors the feedback even before they enter into the peer review ecosystem. And for this work, I build up on some interesting work we've seen in our communities recently. Previous work by John Houghton started to explore the potentials of using LLM to automate social science, where they asked the LLM to simulate the scientific steps done by humans. They asked the LLM to translate directly from the social theory to experimental design and to data generations, and run experiments in a scenario like auction, negotiation, job interview. So their simulation results matched with the theory, which shows the potentials of LLM, but human researchers in their interactions with this model is limited in the study. In a more related examples, prior work done by Mike, Tom Pope, Larry Dog at AI2, I think maybe some audience here, developed a feedback or review generation approach using multiple AI agents, where each agent focuses on different review criteria, such as experiments, clarity, and impact. The results showing that like through collaborations and coordination between agents, they can generate like a fairly higher quality and more specific feedback. This multi-agents paradigm shows the great potentials of providing useful feedback automatically. But our end goal is to facilitate, scaffold, and inspire authors along the way to help them think through this process and improve their research in general. So I'm thinking instead of doing this like fully automatically using like large language model, if we choose to have human and multi-agents to collaborate along the way, there are multiple interesting questions on the interaction side that we should consider. I think AI2 conducted lots of very interesting research related to multi-agents constructions, and the project envision here is to collaborate with AI2 is how we can design a system that multi-agents can like effectively or like creatively scaffold these authors. So if the author would like to ask for feedback, they may want more than single voice feedback. So like how they configure a multi-agents feedback jury that can provide diverse perspective while not bringing lots of cognitive load. There are also many technical challenges of like how to deliver this feedback back to authors if there are lots of voice around the authors. So one method could be provide the overview of the feedback that is not too overwhelming. For example, you can show different dimensions, like where does the feedback comes from, or another dimensions on the review criteria that people can focus on to improve their draft. Furthermore, based on my research, providing contextual process-oriented scaffolding could potentially guide researchers on complex tasks. I think AI2 conducted like research about using multi-agents to generate high-quality feedback. So how to design the system that can like timely provide this feedback back to authors when they read through these PDF could be interesting. Let's take one paper as an example to show the envision experience. This idea thesis paper, I think also from AI2, is the recent paper I'll be reading. And if the author would like to get some feedback on their draft, we can like, here shows some demos of what I envision, I have in mind of building these feedback agents. All the content showing in the small cups are generated by GPT-4o, and you can see here that GPT models does a pretty good job of coming up 5 different areas from where you can get the feedback from. For example, for this paper, they're suggesting you can get feedback from HCI and AI researchers, NLP researchers, UX designers, science policymakers, and research mentors. Let's say if you select a couple of those, the feedback agents can even recommend more specific researchers, including Sam Shi, Justin, Elizabeth, Stephen, Andrew, or some NLP researchers, specifically Martin Northmead, Avin, Tovi, and James. After configuring this feedback jury to make the interaction smoothly, I further consider how to deliver and construct the feedback with the right amount of information, or how to represent this feedback from multiple perspectives back to authors. If you directly ask GPT for feedback, it can give you a long bucket list of things like this. Right? You need to throw it down infinitely to like going through it. So one way we can think of is that we can provide a general like bird view of the feedback at the beginning that user can take actions on. Like user can have like a good sense of where they should focus on in the current stage of the draft. But there's some technical challenges here. Might be like, how could we configure this type of visualization that avoid the high cognitive load? And also like, because there's potential bias of AI generated feedback can be very always positive. So how we need to consider that and then provide a good and accurate visualization here. And then we're thinking when people want to focus on one aspect of feedback and they enter into the PDF, they scroll down the PDF, they can see the feedback highlighted in the PDF on the specific location where they can check and take action on. And then when they click on each specific highlighted sentences, they can get more detailed about what actions they can take on as a suggestion. There's also a small label on the left, maybe like can help inspire the users, just give a quick view of what this feedback is about. For example, this feedback, like this is what GPT generated. I threw this paper content into the GPT, and then this is like asking for potentially what do you want like for area for improvement on the experiment, they give the feedback that is specifically about adding a model detail sections, specifying LLM size, training data set, and retrieval mechanism. They suggested to include AI interpretability mechanisms such as highlighting the source using the AI responses. I think this is just like a simple experiment of what the agents can do, but there's still like questions in the interaction size about how can we locate the feedback at the right place in the PDF, and how like we want to deliver the feedback that has higher quality. Like we want to embed this domain knowledge and maybe knowledge base in like more larger knowledge base to help researchers when they read and like consume this feedback. Another type of feedback we are thinking is we can give them some inspiration questions or reflective questions, ask them to think of, oh, what model did you use? What data set did you use? These are the things you need to consider to add back in your draft. I think I just showed some mock-up I'm thinking in my mind for potential collaboration. I think adding more details about what I think of and what the system may potentially look like could be beneficial for us to communicate. I think like AI to have lots of resources and conducting research related to multi-agents constructions. So I'm envision here is to develop this interaction technique that can use my scaffolding background, use my CI background, and like help these or use multi-agents to better scaffold authors and inspire their research. So these are 3 research questions I think I'm potentially focused on, such as how to configure a multi-agents feedback jury. We want to consider the balance between single voice versus diverse perspective, but we also don't want to include lots of cognitive load for authors. Second research question is how to deliver and construct the feedback with the right amount of information. There's also technical challenging about how to locate it back to the PDF. And maybe potentially we can use information retrieval and generative model together to deliver feedback that has higher quality, which basically embedded domain knowledge and knowledge base. Third is like how we want to present feedback back to authors when they are contextually working on the PDF. What type of scaffolding would the author needs? To give you an overview, my PhD research focused on scaffolding with AI, and I've focused specifically on the peer review ecosystem. So I want to build up like a more like ethical, user-friendly, and efficient peer review ecosystem for researchers. I have been talking with program chairs to discuss potential integration. I'm also invited as a guest for these panels to discuss with other editors in Europe to see how their journal process looks like. I would like to expand this approach into general science area. So like, for example, we can help researchers on literature searching on paper reading. Further scientific advancement change our lives. Every leap forward has been grounded in the pursuit of knowledge. So I would like to keep designing these human AI collaboration technologies that can better support open science in general. I have like most of my publications is in the HCI venue, but I'm also collaborating with other AI researchers on evaluating word model and build benchmark to how to see what the cognitive ability of a foundation model could reach. And also conducting research related to using AI to support work and personalized recommendation about filter bubble. Social science, I conduct some social science and co-design experiments. And I also conduct experiments and systems to ask AI, to ask human to co-create models with AI. Then I would like to end my talk here, and I'm happy to take any question.
I guess I could jump in. This is Joseph Chang. So I really like your line of work around review writing support, and I'm glad that you're looking at it from like an ecosystem standpoint. At the same time, I also find that type of system might also be helpful for authors and readers. So I'm happy that you're also exploring that. I'm particularly excited about when you mentioned that you're talking to journals and PCs about doing maybe like a more realistic study or to look at the impact at the community level. Just wondering, maybe you can say a little more about what the plans are there and what are the consideration and maybe research question that you're interested in.
That's a very good question. I think there's some there's lots of things that we need to consider, like if we really want to deploy a study on a real conference. For example, we need to get consent with reviewers, we get consent from authors, we get consent from the reviewer community. We want to be considerate about how different market stakeholders are thinking of. For example, one difficulties I met in a revision support system is that, the support system focused on the author side, is that lots of their draft, they don't want to share that, or they don't want to share to any AI models at the beginning. So we were thinking of, when we run a user study, we can recruit archive authors, which is they have already put the paper out there. We don't want, instead of putting the paper there and in a void, maybe they can receive some feedback that from the community or from intelligence system, help them to improve their paper. So I think there could be interesting directions to think of. If we really want to deploy some tools with authors, we can reach out to archive authors first, as before even touch on their early draft. I think other challenges is how can we build up this trust and in this community in general. Interestingly, in a study, people don't concern about themselves using the system, but they concern more about other community members using the system. So by talking with different reviewers and program chairs, on the one hand, they think it can save time, but on the other hand, they think the gatekeeping role is also very important. So there should be a line there drawing or there should be a line there, but to set up this line, there need to have some community discussions about could we even use AI in any ways in any aspect of the peer review. So I think for research questions, we're talking about, it will be really interesting to have a general understanding from the society level of how the reviewers or research community perceive AI specific in the peer review.
Thanks. That's a very thoughtful answer. Just one thing to know, we've seen similar things in our survey about how researchers are using language models, that people think the way they're using it is fine, but other people can very much abuse it. So thanks.
Some small interventions they mentioned that it's to make it transparent, you can trace where exactly the part of information is from the AI model, which part of the information is you generate from your own. But then another thing is if you read the information generated from AI model, even though you read some piece of information by yourself, it may also influence the thinking. So I think it's a little bit tricky in a peer review specifically. But I'm happy that you also bring up this concern.
Jonathan has a hand.
I have two hands, but
oh, sorry.
Prove it.
I'm curious if you've thought about other related tasks where reviewing happens. For code review, it seems like that's a pretty well-developed area with a lot of funding, and there's tools for helping people review PRs and also helping authors of PRs to do reviews. And I'm wondering if you've thought about what techniques people have been working on there, and how what's the relationship to what you've been doing?
Oh, that's a very, very inspiring questions. I've been thinking of other areas because I'm focusing on scaffolding with AI. So I think AI could play a role of inspiring and scaffold other people instead of doing the task automatically. So some other task that is complex and multi-stages type of task, I think need this kind of scaffolding more, such as you said, some reviews of, for example, grant writing is also a similar writing, writing task. And also about the code review, I think it's a very interesting task that I haven't seriously thinking about, but when I when you mention it, I think like debugging it and like writing collaborative code, and then or interacting with a notebook within a notebook area. I think like scaffolding can play a really big role there. It can also help learners to gain some skills by like writing code instead of directly ask GPT to help them write the code. They can think or program together with the AI, and as a AI can be a scaffolder there. I think some other task, I think knowledge-related tasks will be more suitable for this type of scaffolding, like general sense-making task, or decision-making task. I think like scaffolding could be helpful of helping them like thinking through each dimensions.
What do you think is different about the kind of support that's useful for reviewing a paper versus code?
I apologize. I didn't study lots of programming language related, but I'm thinking the difference is like for code, the peer review, you always need to make a decision whether it will be accept or reject. So this decision making is a very important steps in this ecosystem. And then like to justify this decision, there could be a review written, there could be a meta review written. So the review and meta review written is built upon all this decision making. I think a little bit different from code review is more like driven by creativity, like or some other like knowledge related task. For example, how to write a function, how to link these APIs, how to combine and ask like let this API work. I think it's a little bit different from like decision driven task. So I think the scaffolding there, like when I think about this, is more because the code writing is the process that have multiple steps. It can like scaffold each steps of coding. I think the only difference might be like it's not like make a decision, think about decision in your head when you keep writing this peer review, but you keep thinking about like different creativity component, about different code functions. I think scaffolding can play a role here of like helping researchers, helping coders to think of what functions could be useful there.
Thanks.
This is Kao. I have a question. So one thing that I think you might not have time to go into detail is looking into the case of meta-reviewer support. And one of the tasks that you have to do as meta-reviewer is like resolving different opinions. Mm-hmm. And I noticed that you didn't mention like there is support of like helping or steering them into how you can resolve differing opinions on a particular point. Is that by design or is by limitation of technology, or it's not a problem that you identify?
I think like when we were definitely thinking about this discussion, but there's some very interesting research showing that maybe the discussion doesn't help about the final decision making. But when we design the study, on the one hand, we want to kind of we want to ask people to focus on the meta review writing task, a more simpler versions of meta review writing task. But the discussion could be very long, so we kind of cut off that. I think a natural follow-up study could be focused on how people perceive these conflicts between reviewers. We don't want the system to be too complex. We design it to control specific component.
Got it. I also have another question.
Sure.
So from the sneak peek that you gave us for the other support, I saw one of the feedback that you gave in the slide that say the action item to do is you just need to run another experiment.
Yeah.
And if I receive this suggestion, as a review point on the second one, it might be I don't think I can do that. So is there any, what is the thought about what are some the limitation of actionable feedback that the system can give to the user?
Exactly. I think this is like, oh, I mentioned this as a technical challenges because I also observed similar things that when I playing around with the agents, they kind of like give feedback that is too ambitious, that impossible for researchers to do in this research cycle. And I think there's a research question there of how to set the expectations for the model and how to set the expectations of human in this system. Like we don't want agents to give like unrealistic feedback. So the feedback they provided should be like embed like some domain knowledge, should be embed some like community common practices, and it should be like embed more like grounded knowledge. I think there should be some technical aspects that can improve this type of feedback, right? Just like what you said, that you don't want them to. I think this is not a really actionable specific feedback because there's no way that you can run it in one day or before you submit a paper. So I think some technical like challenges, some technical solutions need to work on there. Like this is also one of my goals, like how to provide a good feedback, high quality feedback that user can really take action on.
Another follow-up on that is that the writing process can happen in multiple part of the research cycle. It's not just when you are supposed to submit a paper that you do this, right? For example, if there is a feedback on, oh, you actually should run another experiment when I wrote a research proposal for the project, that could be a reasonable point for that type of feedback as well. And one way is like maybe they could also, instead of like thinking about just providing feedback on the finished, polished transcript, you can also thinking about the feedback that you give to a research plan.
That's a very interesting point, and I agree with that. I think the feedback should adapt to the workflow, which also means adapted to the stage of the research. Like maybe for early draft, you only have a guideline, you only have an outline. Maybe they can provide feedback to researchers on how to run the experiments. What are good and what are drawbacks of using within subject versus between subjects, which model they should pick. I think these feedback could be very helpful at an early stage. And then the example I'm showing here is that when you get a draft, on the archive, you want to craft it or last minute submission, you can get this type of feedback. But I think that will be more interesting because there will be more support needed. For example, it can support users of writing code, run a statistical analysis, or it can support users to writing codes of how to run another GPT model or another language model.
Thank you. Any other question? All right, and I think we are at about time as well. Thank you very much, Lou. Anything else, Brennan?
No, we should be all good. And thank you, Lou, for your presentation.
Thank you so much. Sorry, I cannot see the screen, but I'm really glad that I see all of you.
Have a good day, everybody.
Thank you. Have a good day.
Bye.
Bye.